Okay, I just want to thank people for reading my blog still, checking up on my research. And this is the book I got in the mail recently from a used bookstore in Cleveland, Ohio. And they bought the original factory that made Twinkies, which is a great Americana health food, or not really, but it's I, I remember indulging in Twinkies when my neighbor friend's mom offered me Twinkies when I was in first grade, and wow, anyway. Okay, so I got this book because it was cited by my quantum physics professor, Herbert J. Bernstein. But it turns out he did not author the chapter that he cited, but he did administer the grant that the author used, and the author got the Nobel Prize in 2022. He was one of 3 authors, and so it's kind of fascinating to see like the early work of somebody who got the Nobel Prize. This is part of a NATO science series, and so luckily it was in Cleveland used, and kind of a really cool independent bookstore. And so yeah, it's an old school book when they just have like a typewriter setting, typeset, 1985. Okay, so I took Professor Bernstein's class 4 years after this book was published. So we're going to go right to the chapter, the article that he cites, but it's actually authored by ZEILINGER, Anton ZEILINGER, who got the Nobel Prize. He was one of 3 people in 2022. So it's quite amazing that this is about the Aharonov-Bohm effect. Now, the reason I want to talk about this is because if you look at the other articles, they got a whole section on discussion of the Aharonov-Bohm effect, and the article by Longer is the one I mentioned before. I did a blog post on it where he's calling the Aharonov-Bohm effect magical, non-local. So he's saying that non-locality is magical. And I found that kind of interesting because obviously he means, in a derogatory sense, magic. But for me, I've experienced magic, so I know magic is real. So it's kind of funny that, and then this is in 1985, right? But I didn't realize that this same author, Longer, he kept writing about how the Aharonov-Bohm effect wasn't real, and he also claims that black holes aren't real too and stuff like that. But then he is cited by Lev Zeidman, who is a researcher that's part of the, I don't know if he works with the Aharonov-Bohm or Aharonov research group, but he's lecturing recently. He also claims the Aharonov-Bohm effect is not real. And that's very recently, and he's citing Longer. So from 1985 up to current times, you have a competing claim that the Aharonov-Bohm effect does not exist. And yet in 2022, you have somebody who got the Nobel Prize based on the Aharonov-Bohm effect being, existing and being real. And what's ironic about this is that Basil J. Hiley actually joked to David Bohm that he should get the Aharonov-Bohm effect, and then Bohm said, no, it should go to the original inventor. And I cite that on my blog too, where I might have done a video on it, where Basil J. Hiley, he published a article on reviewing the Aharonov-Bohm effect. I think it was in 2013, the history of it. And so, okay, let's get into the article now, page 311. So, you got a lot of high-level physicists here. This is all top-level physics. Obviously, if one of the guys, this author, gets the Nobel Prize in 2022. So now my professor was working in the same. This is the neutron interferometry lab that Herbert J. Bernstein cites. So he was working in the same lab at MIT. And he administered the grant through Hampshire College. So So the reason I wanted to do a video about this is because I was just reading somebody who was reviewing my blog, and I review what other people read on my blog. I review my research, and this has to do with the concept of symmetry, because when the people that dismiss the Aharonov-Bohm effect, they do it on the basis of gauge theory, and so they're assuming a symmetric space-time for gauge theory. And so they're arguing that you don't need quantum physics to explain the Aharonov-Bohm effect, and you can just do it from gauge theory. And then this goes back to the argument about what is time, nonlocality in the Platonic realm of forms, where Plato argued that the number 2 originated as a symmetric duality before it was the unit 2 based on discrete counting of before and after, or the past and the future. So Aristotle said, well, you can have 2 different units appear at the same time, and therefore there's nothing inherently prior to duality as a unit. And therefore Aristotle rejected the Platonic realm of forms based on the concept of two-ness. But that concept of two-ness meant you could then combine geometry and arithmetic for the creation of irrational magnitude. And so that's the secret origin of the symmetric space-time continuum as irrational magnitude geometry. And that's essentially what the same argument is about the Aharonov-Bohm effect, that the people who claim you don't need quantum physics are basically reiterating the argument of Plato that you can just start from this inherent two-ness as symmetric space-time that's irrational magnitude of geometry in space, whereas the quantum non-locality means you have a time non-locality that's inherently asymmetric. And so it's not that time doesn't exist, but that it's the future and the past overlapping. And this is what Basil J. Hiley argued was the truth of Bohmian physics, was this asymmetric time that's non-commutative, so it's an eternal motion of the future and the past overlapping. And Lee Smolin actually had a falling out with a famous physicist, I have one of his books, but he worked with Alain Kahn. But Lee Smolin was also a student of Herbert J. Bernstein, and so Lee Smolin came up with this concept of fundamental time, where he also argues that time actually exists inherently on its own, and it's also inherently asymmetric. And this is what Roger Penrose argues as well. But the Platonic symmetric space-time view is that time does not exist. And so that's what this debate about Aharonov-Bohm effect is really about, the meaning of time. That's what my claim is. Now, have I gone into all the minutia about the Aharonov-Bohm effect and gauge theory versus quantum physics? No, because David Bohm and Basil J. Hartley, they both just assumed the Aharonov-Bohm effect is real, it exists, and that's what the 2022 Nobel Prize was based on, the fact that the Aharonov-Bohm effect exists because it's the same as Bell's inequality. It's the same concept. So, in my view, it's already proven. But it's still interesting to see what other people are trying to claim. So here you have an interferometer. And so then they go into that, and then he gets into the neutron interferometer here. So when you're using a neutron interferometer, then obviously you can discount the charge as gauge theory. Okay, so obviously Professor Herbert J. Bernstein, he was the first one to create the thought experiment about the neutron Stern-Gerlach experiment that would, neutron interferometry, that would then prove that you could observe spin because there's no charge when you have a entangled neutron that's split. So this is another physicist at Hampshire College, I think, or maybe he was at MIT, but he was also part of the same research group with Herbert J. Bernstein. Okay, so it's kind of fascinating that in the same exact book, people are arguing, no, the Aharonov-Bohm effect doesn't exist, So here's the article where he says it's magical nonlocality. And the let's see if I can find it here. Here it is. There is no magic or non-local action. Therefore, there is no magic or non-local action. So, this was Basil J. Hiley's big point, is that most physicists cannot accept non-locality. And the reason they can't accept it is because they can't accept non-local time. And so you really do have this deep divide at the foundation of physics about what is the truth of reality. It's pretty fascinating because, of course, most people aren't even aware of this debate. Because even after the Nobel Prize was given for the Bell inequality, you still had a lot of physicists debating what does it actually mean, you know. And so that's why Professor Jean Brimond, he's focused on the Bell inequality experiment as non-locality that's only truly understood using the de Broglie-Bohm model of reality. So here we go. This is fascinating. Global effects are fundamental in geometry, but non-local effects of forces are extraneous to quantum mechanics. They belong only to a kind of quantum magic. So it's exactly what Einstein was calling it telepathy, and he meant it quite literally. Like he was, and that's just where they have debates in quantum physics. Like when they say magic and telepathy, they really mean like the paranormal and telekinesis and so that's why De Broglie's protege Olivier Coste-de-Beauregard, he argued that the paranormal really does exist due to the de Broglie-Bohm model of reality, and so his research is what the CIA relied on when they did the remote viewing experiments at the Stanford Research Institute. So I just wanted to prove that, there's still this debate going on about the Aharonov-Bohm effect. And so what Basil J. Hiley emphasized in 2022 is that non-commutativity completely changes quantum biology. So when they're talking about non-locality being magical, what they really mean is quantum biology. And when you understand it's actually the non-commutativity of time and frequency as a secret of quantum non-locality, then you understand that it's also the secret of magic. Okay, I think we get a counterclaim here. The suggestion that the Aharonov-Bohm effect is not part of quantum physics, or that it can be removed from quantum mechanics without ruining the theory, is an important one for many reasons. Removing the theory would remove justification for Dirac's charge quantization law. Interesting. I remember this law from like 20 years ago. I was really fascinated by this because it's an integer-based origin of charge. The AB effect cannot, in fact, be removed, except by spoiling the conservation and quantization of angular momentum. Okay. So this book is actually a raging debate going on, despite being such a dry appearance. Who would guess that this book is a raging inferno? So, okay, let's get into this one. So he's hanging out at Argonne National Labs. Term flux conclusion. I do not believe that challenge has been accepted for theory of Okay, so it's getting into the magnetic monopole. That's where you get into Schwinger. Okay. One second. Well, so my point is obviously that I have to really study it in detail to get into the whole nitty-gritty. When in fact, if you do quantum biology, you rely on logical inference of time. So you're listening to the source of time and you're bypassing the symbolic realm of science and language. And this was the big point of somebody who used to comment on my YouTube channel. I was like, well, it's just mathematics, it's not the truth of reality, it's just symbols. And that's true. That is true, except for the fact that, science is our religion of today. We live in the age of science. An infinite magnetic string flux line. So that's what a flux line is. Here's some comments on the alleged non-existence. So it's like, well, has Lev Zeidman read this book? Lev Zeidman needs to read this book because this book contains debunking of the sources he's relying on. So you have this big debate about discontinuity and the calculus and all sorts of stuff. It's interesting because you're seeing a big debate about mathematics and physics and what it all means. And so now he's getting into spherical harmonics. Okay, that's all. This paper cites the Aharonov-Bohm effect. Stability of matter, Walter Turing. I have the impression this is an important paper. Walter Turing was a famous physicist. Okay, so anyway, this is my point that this raging debate about whether it exists or not. So even in 1987, I had no idea that my own professor in this was 1985. So 4 years later, my own professor was teaching something, and I had no idea it was still being debated. It's just like a lot of physicists didn't believe in non-locality. And so I was being taught revolutionary physics without realizing it. But the funny thing is that for me, it just corroborated what I already knew. So, anyway, this is a cool title of a paper. Are Dirac electrons superluminal? Well, I don't know. Are they? So there's a lot of stochasticity, randomness stuff. That's when this was all the rage. Let's see. A lot of interesting papers in here. I mean, if you're really a nerd, which I'm not. I don't even do these equations. I don't do calculations. But there's one on continuity measurements. Ooh, Jordan algebras. Okay, let's check out this Jordan algebra one. Because we know Jordan algebra is non-commutative. I don't know if it's the same as the Jordan product. Let's see here. Well, it's a short paper. Mm-hmm. 1934. Okay, so got a lot of stochastic stuff. Ooh, here's Alain Aspect. He was one of the winners of the Nobel Prize in 2022. So, see what he has to say. As conclusion, we shall emphasize that this effect is a single photon interference effect. I'm trying to read it through the phone. Yeah. Okay, so this is basically part of what would become Bell's inequality. That's pretty fascinating. Okay, so we got the round table discussion. It's kind of weird that they put ZEILINGER not in the Aharonov-Bohm discussion category. And gravity. Yeah, so all these things are still up for debate, obviously. This is 35 years ago. This is 40 years ago, 1985. And they're still debating these topics after 40 years. But since the Nobel Prize was given for Bell's inequality in 2022, then we know which side of the debate won officially, and yet they're still debating. So that's why Basil J. Haley said in 2012, "Nobody understands me," when Jack Sarfati said, "Oh, isn't it just the same as a gauge theory?" So when he said that, he was going right back to the same debate about dismissing the Aharonov-Bohm effect as a gauge effect. And so then Basil J. Haley just said, "Nobody understands me." It was pretty funny. And yep, so the essence of the Aharonov-Bohm effect is that a magnetic field not accessible to the particle gives origin to physically observable phenomena. Now I shall consider again the example of the plane rotator. Okay. Oh, okay. Yeah, so this is where they're trying to dismiss it. Anyway, I'm gonna watch Lev Zeidman's talk, but since he doesn't, I don't think he is aware of the counter response. In other words, you have you have ZEILINGER present the Aharonov-Bohm effect with neutrons. Then you have these two papers, and then you have three papers that dismiss it, the Aharonov-Bohm effect. And then you have Peshkin giving the counter argument. Theories without Aharonov-Bohm effect misrepresent the dynamics of the electromagnetic field. So you have this deep discussion going on. And then you have more of the Aharonov-Bohm effect. Anyway, obviously a deep debate that's still going on with Lev Zeidman. But the question is has he seen these counter claims against the papers that he cites?